In this video we give proof of the properties of the natural logarithms using techniques from calculus. These are the important properties, these four properties of the natural logarithms. That the natural logarithm of 1 is equal to 0. The natural logarithm of a product of two numbers is the natural logarithm of the first number plus the natural logarithm of the second number. The third property is that the natural logarithm of r to the power of k equals k times the natural logarithm of r. The fourth case is that the natural logarithm of the quotient of the two numbers is the natural logarithm of the number that is in the numerator minus the natural logarithm of the number that is in the denominator. So we have natural logarithm of x equals the integral from 1 to x 1 over t dt. Alright, so for the first one, the natural logarithm of 1 is the integral from 1 to 1, 1 over t dt, which is equal to 0 by the properties of the integrals. If the bounds of integration are the same, the integral is equal to 0. The natural logarithm of the product of the two numbers is the integral from 1 to a times b, 1 over t dt. I can split it like that. So let me show you what I have. The integral from 1 to a 1 over t dt plus the integral from a to b 1 over t dt. Now let's calculate this integral here. The integral from a to a times b 1 over t dt. I will do a substitution. So I will set w equals t over a. dw over dt is 1 over a. So from here I have that dt equals a dw. T is the product of a times w. And now I also have to change the bounds of integration. So for t is equal to a, w is equal to a over a, which is 1. And for t equals a times b, w is a times b over a, which gives me b. So I can simplify the a's, and I have the integral from 1 to b, 1 over w dw, which is the natural logarithm of b. So I go back here, and I have that, so this integral is the natural logarithm of a, plus the second integral, this one, which is I1, which is the natural logarithm of b. So what I got is the natural logarithm of the product of a times b equals the natural logarithm of a plus the natural logarithm of b. So far I have secured the first two properties. Now the third property says that the natural logarithm of r to some power k equals k times the natural logarithm of r. Alright. Let's take the derivative of the function r to the power of k with respect to r. I use the Leibniz notation. It's 1 over r to the power of k of the natural logarithm, You take the derivative with respect to r of natural logarithm of r to the power of k. It's 1 over r. This is a differentiation, basic differentiation techniques. And here is k times r to the power of k minus 1. K is just a constant. So this is in the numerator r to the power of k r to the power of minus 1 over r to the power of k. I get k over r. Now let's take the derivative of this function at the right hand side, d over dr of the function k natural logarithm of r is k times the derivative of this function here, which is 1 over r, so it's k over r. So what do I notice? That the derivative of natural logarithm of r to the power of k equals to the derivative of the function k natural logarithm of r. So what I do here is integrate on both left and right hand side of the equation, and I have that the natural logarithm of r to the power of k equals the k times natural logarithm of r plus natural logarithm of a constant. I plug in r is equal to 1, so I have natural logarithm of 1 to the power of k equals k natural logarithm of 1 plus natural logarithm of c. Of course, these terms vanish, and I have the natural logarithm of c is equal to 0, so I can use that natural logarithm of 1 is 0, and from here c equals 1. So what I get finally is that natural logarithm of r to the power of k equals k times the natural logarithm of r. This is my third property. The other property is that the natural logarithm of a quotient of two numbers is the natural logarithm of the numerator minus the natural logarithm of the denominator. In order to prove this result, I will combine this property here, taking down the power inside the argument of the logarithm, and also I will use that this property here with the natural logarithm of the product of two numbers. Alright? So, natural logarithm of the ratio a over b is the integral from 1 to a over b 1 over t dt. I can split it. I can split it like that. Of course, this one is the natural logarithm of a plus I2. I can calculate what is the integral I2. How do I calculate this one? I do a substitution. So u is equal to t over a, du over dt equals 1 over a, dt equals a du. And from here t equal of u times a. Now I have also to change the bounds of integration. So for t equals a, I get that u is equal to 1. Alright. And now for t equals a over b, u is 1 over b. So I go back here and I have natural logarithm of a plus natural logarithm of 1 over b. I can use negative power here, b to the power of minus 1. And now I have proved that when you have the sum of logarithms of two numbers, you can take the logarithm of the product of the two numbers. So it should be natural logarithm of a over b. And I have proven my last result.